In part C, we are told that after a long time, the switch has been in position A, and the charge on capacitor 1 is Q0, and capacitor 2 is uncharged. In part C, we are told that at time C1, the switch is moved to position B, and we need to say whether the current is directed up, down, or there is no current in resistor 1 when the switch has been closed. So what we need to note here is that this will be the positive side of the capacitor because that corresponds to the positive side of the battery. And we know conventional current flows away from the positive side of the battery. Therefore, the correct answer will be up, and it's because top plate of the capacitor is going to be positive. Is positive. In part 2, we need to determine an expression for the total charge on the positive plate of capacitor 2 after some time t. So what we need to note here is that both capacitors have the same capacitance according to the question. So since they have the same potential difference and charge has to be conserved, the charge on capacitor 2 will simply be Q0 over 2, and so will the charge on capacitor 1. Their sum has to be 1, so that charge is conserved. And they have the same capacitance, so the ratio of their charge will be the same. In part 3, we need to derive an expression for the total energy dissipated in resistor 1 immediately after the new state steady conditions have been reached, and the total energy dissipated, the energy loss, will be the final energy minus the initial energy, which we can express in terms of energy stored in capacitors. Initially, we only have energy in capacitor 1, and finally, we have energy in both of these. So we need to find the difference of these. So at the end, we have energy in both capacitors. Energy is 1/2 Q squared over C. So this will be 1/2 times 1 over C times Q0 over 2 squared, and the other capacitor will have the same energy. And initially, we only had one capacitor, which had charge of Q0 and capacitance of C. So if we do this, we get this is Q0 squared over 4C minus 1/2 Q0 squared over C. And so this will be minus Q0 squared over 4C.